welcome back to my channel. This is Madam Chan here. Today we are going to continue with chapter 6, that is the linear inequalities in two variables. Over here we have two subtopics involved, which is linear inequalities in two variables and also the systems of linear inequalities in two variables. So today we are going to enter the first subtopic, linear inequalities in two variables. Here it is divided into three main parts. The first part that we are going to look into later on is on how to represent a situation in the form of a linear inequality. This one you have done it before in Form 1, the same topic, linear inequality. And then second, we are going to verify the conjecture about points in the region that satisfy a linear inequality. What does it mean by conjecture over here? Conjecture from the Cambridge Dictionary that I have found out, the meaning given is an opinion or judgment that is not based on proof. Sorry, a typing error over here. And then it is also similar to guess, presumption, assumption. Okay, and the last one that you are going to see later on is on determine and shade the region that satisfy a linear inequality. Okay. So before we continue with the first part over here, we are going to see what you have learned previously. Previously, you have learned the highest power of a variable in a linear equation is 1. For example, here, the value of the variable of x and variable y, the power is 1. And then you also learn the linear equation in two variables, x, y. And then a, b, and c over here, they are the constant. So for 6.1a, we are going to learn how to represent a situation in the form of a linear inequality using these four different inequality sign. Okay, the first one and second is easy, that is greater than, and the second one is less than. And then for the third one, greater than or equal to, there are a few keywords that you have to look into next time when you see this word. At least, it means greater than or equal to. Not less than, also the same, greater than or equal to, or minimum. Okay, and when it comes to less than or equal to, so the few keywords can be at most, which means less than or equal to, not more than, also having the same meaning, and maximum. Now we look at example 1. Jenny wants to buy some storybooks and reference books at a book exhibition. She finds that the price of a storybook is Rm39 and the price of a reference book is Rm11. The maximum amount of money that Jenny can spend is 100. Will represent the above situation in an appropriate form of linear inequality. So you got to represent the situation. Okay, to represent the situation, first you have to represent the storybook and also the reference book by using a variable. For example, let x equal to storybook and y equal to reference book. It's up to you what is the letter that you want to use over here. You can use A and B, or X, P and Q also can. Okay, so for storybook is 39 ringgit. We are going to use 39 multiplied by x, and then reference book is 11, so plus 11y. Here, the maximum amount, remember when you see the word maximum, meaning that it is less than or equal to 100. So this is the linear inequality that we can form. Or sometimes if you didn't write down the y in front, maybe you also can write it at the back like this. It's also acceptable, 100 minus 11y, or it can be 11y is less than or equal to 100 minus 39x. Okay. Now we look at example 2 here. Puan Hayati wants to buy mineral water for school sport day. The cost of a small bottle of mineral water is 90 cents and for a large bottle is 150. We'll represent the purchase of both sizes of mineral water in an appropriate form of linear inequality if the allocation from the school is 150. So if the allocation given is 150, meaning that it is less than or equal to. Same thing, you are going to make assumption. Let the small bottle of mineral water represent using S, and then the large bottle of mineral water using L. Okay, so 90 cents here, 0.9S plus 150L is less than or equal to 150. Okay, if you can see the linear inequality that we have over here is in the form of decimal, right? So when you see it's in the form of decimal, you have to change it into a whole number. It's the same when it comes to a fraction. So whenever you see a fraction, you have to change it to a whole number. So how do we change the decimal here into a whole number? Is by multiplying 10. Okay, 0.990 multiplied by 10 becomes 9s plus 1.5 times 10 is 15, and then 150 times 10 is 1005. So when you look at this inequality, also we can find out all the constant over here can be divided by a number, right, which is 3. So 9 divided by 3 equal to 3, 15 divided by 3 equal to 5, and 1500 divided by 3 equal to 500. So that's the final answer. Okay, now we are going to see the second part, that is to verify the conjecture about points in the region that satisfy a linear inequality. Okay, what is that? You have learned in Form 1 on how to represent the linear inequality in the form of number line. This is number line, right? And then now you are going to learn on how to represent the linear inequality in the form of Cartesian plane, like this. Okay, so in the form of Cartesian plane, it will be represented using x-axis and also y-axis. This line here represents x is equal to 1. So when x is greater than or equal to 1, it is the region on the right. What are all this about? We are going to look further into it. Okay, now look at types of region generated on a Cartesian plane when a straight line is drawn. The first one that we are going to see here is y equal to mx plus c. Remember, m over here is to represent the gradient, right? So when the m over here is positive, meaning that the graph is going up, like this. Okay, so when it comes to y equal to mx plus c, this part on top of the line is called region above. Okay, and the one that on the bottom or at the bottom of the line is called the region below. Okay, next we have the gradient of the positive equation already. Now we look at the gradient in negative form. So when it comes to a negative gradient, the graph is going down. Okay, so from the graph given, the one that on top of the graph, it is labeled as region above, and then the one at the bottom is region below. Okay, so we have the graph with the gradient. Now we look at the graph without gradient. This is the graph without gradient, y equal to h here. When y equal to h, meaning that the value of y-axis over here is equal to h. So to identify the region, the one on top of the graph, it is the region above, and then the one at the bottom is the region below. So next, when it comes to x equal to k, meaning that the x-axis here, the value is k. Okay, so to identify the region on the left of the graph here. Okay, and then this part is identified as region on the right. Okay, now there are a few things that you have to take into account here. All the points that lie on the straight line satisfy the equation y equal to mx plus c. What does it mean here? Meaning that if you have points fall on the straight line, meaning that the point satisfy the equation y equal to mx plus c. If the point lie in the region above, then it will satisfy the inequality of y greater than mx plus c. So like this part here, region above, it is y greater than mx plus c. When it comes to the point that lie in the region below, then it will satisfy the inequality of y less than mx plus c. So this part, the region below, it will satisfy y less than mx plus c. Okay, so there are few things in your book given here with the question here. The gradient of the straight line y equal to h is 0. This one, y equal to h. Why is it so? Can you tell me? And then the second question, why is the gradient of a straight line x equal to k undefined? This one here. Why is this line undefined. Discuss. Okay, you think about it first, and then I'll get back to you at the end of the lesson. Now we continue. So it's about determining the point right now. We can determine the point by drawing the graph or without drawing the graph. Let's look at the example given here. Draw the straight line y equal to negative x plus 1 for negative 1 less than or equal to x less than or equal to 5. So if you still remember, this is the range, right? Plot the points 1, negative 2, 4, 5, 4, negative 3, and then determine whether the points plotted satisfy y equal to negative x plus 1, y greater than negative x plus 1, or y less than negative x plus 1. So for y equal to negative x plus 1, this is the equation. What do you need to do is, you need to plot the graph first. Okay, to plot the graph, you will need a table of value. Do you still remember? You learned this before. So you have to make or give any value for the x. For example, I give a 1 over here when x equal to 1, this part. Negative 1 plus 1, so the value of y will become 0. And then when the x is 2, represent the x with 2, negative 2 plus 1 will become negative 1. After that, we plot the graph. Okay, when x is 1, y is 0. So 1, 0 is over here. And then 2, negative 1. 2, negative 1 is over here. So we can see basically it is going from the diagonal to the diagonal, right? So I'm going to draw the graph like this, from diagonal to the diagonal. Okay, then we are going to plot the point. First one is 1, negative 2. 1, negative 2 is right here. And then we have the second point, 4, 5. This is 4. This is 5. After that, we have 4, negative 3. This is 4. This is negative 3. Okay, so refer back to the question. Determine whether the points plotted satisfy y equal to negative x plus 1. If it satisfies y equal to negative x plus 1, like I've told you just now, right? The points will be falling or lies on the straight line. So we look for the point that lie on the straight line. This is the point. The coordinate is 4, negative 3, meaning that 4, negative 3 satisfy the equation y equal to negative x plus 1. And then for the next one, for y greater than negative x plus 1, the point, when it is greater, the point must be on the region above. Okay, so can you identify which point lies on the region above? This one, right? The coordinate is 4, 5. So point 4, 5 satisfy the inequality y greater than negative x plus 1. Okay, and for the last one, y is less than negative x plus 1. If it is less than, meaning it is at the region below. So region below is here. The only coordinate that we can find is this. That is 1, negative 2. So this is the answer. Okay, now we look at example 4. Given the linear equation y equal to negative 6x plus 3, without drawing the graph right now, just now we draw the graph, right? Without drawing the graph, determine whether the given points satisfy y equal to negative 6x plus 3. This is the equation. Y greater than negative 6x plus 3 or y less than negative 6x plus 3. So for all of these three questions over here, you are going to draw the table of value by finding the value of x and y for the equation. This is the equation here, okay? So first, draw the table of value by writing down y is negative 6x plus 3, like this. Okay, when the value of y is 5, this is the value of y, okay, from the coordinate. This is x, this is y. So y is 5. The x will be represented by 2. So you substitute with 2. Negative 6 times 2 is negative 12. Negative 12 plus 3 is negative 9. Then you compare the value of 5 and negative 9. 5 is greater than negative 9, right? Therefore, the point satisfy y is greater than negative 6x plus 3. As long as it is greater, meaning that it satisfies the inequality over here. It is the same. Okay, now we look at the second example here for -2 and 2. So this is the value of x, this is the value of y. You are going to draw another table of value by filling in y and -6x plus 3 like this. Y on the left and -6x plus 3 on the right. So the y is 2, you write down here as 2. -6x, the x right now will be represented by -2. So -6 times -2 is a positive 12. Positive 12 plus 3 is 15. Then you compare 2 and 15. 2 is less than 15. Therefore, it satisfies the inequality y is less than -6x plus 3. Okay, we look at the last one here. Same thing. You are going to draw the table of value by filling in y -6x plus 3 like this. Okay, now the value of y is 9. The value of x is -1. So you substitute -1 times -6 is a positive 6. 6 plus 3 is the 9. The value of 9 is equal to 9, right? Therefore, the point -1, 9 satisfy y equal to -6x plus 3, meaning that it lies on the line right for this one. Okay, now we enter the third part of this subtopic, that is to determine and shed the region that satisfy a linear inequality. You got to remember earlier we learned about the region above, the region below, the region on top, the region on the left, the region on the right, right? So we are going to shed the region right now. Okay, for this equation here, you got to remember before we shed the region, you have to see this is y is equal to mx plus c. So if it is on top of the line or the equation, it represents y is greater than mx plus c. If it is at the bottom, then it represents y is less than mx plus c. Okay, then for this one, if this line here is representing y equal to h, this part will be y greater than h. And then the one at the bottom, less than h. And then if it is a straight line like this, a vertical line, for x is equal to k, this equation here. So on the right will be x greater than k. On the left will be less than k. Can you remember? On top of the line, for example, again, we go back one more time. On top of the line here is greater than. Below, less than. On top, greater. Below, less than. On the left, less than. On the right, greater than. Okay, now we will look at the relationship between a point on a Cartesian plane with the inequality. So this is a symbol of greater than and this is less than. The points that lies in the region above or below a straight line y equal to mx plus c. And then the straight line is drawn using a dashed line. Okay, I'm going to underline this so that you can remember. Dashed line for greater than, less than. When it comes to greater than or equal to and less than or equal to, then you have to use a solid line. For this one, the point lies on the straight line y equal to mx plus c, including the region above or below. Okay, what does it mean over here? You can look at the graph given. So this is the line of y equal to mx plus c. Okay, this part here is y greater than mx plus c. Why do we use dashed line? Because it is greater than. Okay, because of this symbol, greater than, less than. So we use dashed line. Okay, and then the region do not include the points that lie on the straight line y equal to mx plus c, meaning that it does not include the point here. It can be only the point on top of the region and at the bottom of the region. Okay, now we look at the second one. This is the straight line here. So when it is a solid line, meaning that it is for greater than or equal to then and less than or equal to. So the region include points that lie on the straight line y equal to mx plus c. So the point on the straight line is include. This one, the point doesn't include for this one. Okay, now we look at example 5. Shed the region that represents each of the following inequalities. This one is from your textbook exactly. We see how to shed the region. For the first diagram here, we have y greater than 2 over 3x plus 2. So When it is greater than, it is dashed line like this. Okay, and then greater than, it is on top of the graph. So this is the region that you have to shed. Okay, then we look at B. Y is less than or equal to x minus 1. So when it comes to x less than or equal to, you are going to use a solid line like this. Okay, less than or equal to, this is on top, right? On top means greater than. So less than or equal to, we have to shed the region below. Okay, and for C, y is less than 1. This is dashed line because of the symbol. Less than means at the bottom. So you just shed the region at the bottom. Sorry, you got to shed nicely, not like mine over here. Then we look at the next 3 figure here. D, y is greater than or equal to negative 2x minus 2. So this is the graph over here. Greater than or equal to meaning that it's a solid line like this. So greater than is supposed to be on the graph here. You compare, because this is a line, this part here will be below the graph, so you don't shed this part. This part is not correct. You only shed the one on the right. Okay. E, x is greater than negative 3, so this is the line. Greater than means on the right, so you shed the right hand side here. Make sure you use ruler, don't just use freehand like me. And then y is greater than negative 2, so this is the graph here. When it comes to greater than, then you shed the region above. Okay. The region below here represent by what? The region below represent by less than. Okay. So we look at the next example here, example 6. Draw the graph and shed the region that represents each of the following inequality. So now you have to draw the graph. For x is greater than or equal to negative 2. So I've provided a Cartesian plane over here. X is greater than equal to or equal to negative 2. So you just refer to your x-axis looking for negative 2, this part here, right? So you just, because it is greater than or equal to, therefore it is a solid line. So you draw a straight line using a ruler straight down. Okay, and represent it using x is greater than or equal to, x is equal to negative 2, because this is the line. So when it comes to x is greater than or equal to negative 2, it is the region on the right. You have to shed the region, this part here. Okay, now we look at question B here. Y minus x is less than 2. So before you do anything, you have to change it into the general form, right? Do you still remember the general form? General form y equal to mx plus c. So I'm going to move the negative x here to the right. Okay, which means it will be y is less than x plus 2, like this. After that, to draw the graph, I'm going to need a table of value, because this one I have to substitute the value and draw the graph. It's unlike this one because we have the value of x straight away. Okay, but this one we have gradient. So represent the value of x using 0 and 1. It's up to you what is the value of x you want. Any of the value as long as it can fit into your Cartesian plane. So when x is equal to 0, this x is equal to 0. So 0 plus 2, the value of y will become 2. And then when x is equal to 1, I represent the x with 1. 1 plus 2 equal to 3. So we can draw the graph on the Cartesian plane already. X is 0, y is 2. So x is 0 is over here, y is 2. This is the point. And then x is 1, y is 3. X is 1, y is 3. This is the point. Okay? Same thing. From diagonal to diagonal, I'm going to join them up. Okay, make sure you use ruler. Okay, so this is less than or equal to. Can I do a solid line like this? Cannot, right? So I'm going to reverse it. Sorry. I cannot undo what I've done. So I'm going to change the color of my pointer. I'm going to use some Okay, green. So remember, if it is less than, the line must be a dashed line because it does not include the value or the points. So we must use dashed line over here. It's not very clear. Sorry, I change again. The pointer become red. Okay, it must be a dashed line like this. Yeah, it's clearer now. Clear. Okay. So when it comes to less than, meaning that the region is at the bottom. So you shade this region at the bottom. Okay, don't forget to write down the equation. That is y equal to x plus 2. Okay, so we are reaching the end of the lesson. Remember just now I prompt you with 2 questions. Okay, this is the one. The gradient of the straight line y equal to h is 0. Why? For this one, why is it 0? How to find the gradient? Do you still remember? We find the gradient by using the changes in the value of y, the vertical line here, divided by the changes in x. So if you look at this line over here, do we have the value of y? We don't have any value of y, right? So meaning that it is nothing, 0, divided by a something. 0 divided by something, you get a 0, right? That's how you get a 0 for the answer. Whereas for this one, it is, for example, the vertical changes here is a 1, right? 1 divided by nothing. There's nothing here. So 1 divided by nothing is undefined. Okay, so that's all for the lesson today. I hope you enjoyed the video. Then I'll see you again in the next lesson. Make sure you remember to do the homework, okay? See you.